This is a video from section 5.3. The directions say to evaluate the integral. We're going to start with example 1, and we're going to take the integral from negative 1 to 1 of x to the 100th power dx. And we need to find the antiderivative of x to the 100th. So in other words, can you give me a function so that when I take the derivative, I get x to the 100 back? And the answer is 1 over 101 x to the 101. That's the function whose derivative is x to the 100th. But remember that the lower limit is negative 1 and the upper limit is 1. This is called a definite integral. And so we're going to evaluate from negative 1 to 1. And so what I'm going to do is I'm going to pop in that upper limit of 1. And I'm going to pop in that lower limit of negative 1. But 1 to 101 is 1. And so we get 1 over 101 minus 1 over 101 times, and negative 1 to an odd power is negative 1. So this is 1 over 101 times negative 1. And so the answer here, well, this is 1 over 101 plus 1 over 101. So this is 2 over 101. And that's how you do the first one. So let's take a look at example 2. It's very important that you guys get a feel for how to do these definite integrals, especially as you progress in calculus. So we're going to go from 0 to 1, the integral of 1 minus 8v to the third power plus 16v to the 7th dv. So we're going to take each term at a time. So the antiderivative of 1 is going to be v. That's the function whose derivative is 1. Minus 8 times 1/4 v to the 4th. So I add 1 to 3 and then divide. Plus 16 times the antiderivative of v to the 7th is v to the 8th over 8, or 1/8 v to the 8th. And I'm going to go from 0 to 1. Pop the 1 in, pop the 0 in, and subtract. But before we do, I'm going to write this as v minus 2v to the 4th plus 2v to the 8th from 0 to 1. Okay, so I'm going to get 1 minus 2 times 1 to the 4th plus 2 times 1 to the 8th. Okay, so I'm going to take that quantity. Okay, so notice I replaced the v with 1. Now replace the v with 0. 0 minus 2 times 0 to the 4th plus 2 times 0 to the 8th. That's all 0. And so I get 1 minus 2 plus 2. The answer is 1. That's how you do example 2. Example 3. Suppose I had the integral from 1 to 8 of x to the negative 2/3 dx. Now, the way you integrate these type of things is we're going to add 1 to the exponent, so it's x to the negative 2/3 plus 1. But I'm going to divide by negative 2/3 plus 1. And I'm going to take that and I'm going to evaluate from 1 to 8. But remember, negative 2/3 plus 1, or 1 minus 2/3, is the same as a third, right? And so I'm going to move that. Well, also, let's write this. So 1 over 1 over 3 is the same as 3. So this is 3x to the 1/3 from 1 to 8. So I'm going to replace x with 8. That's the upper limit. And I'm going to replace x with 1. That's the lower limit. And I'm going to subtract the results. Okay? And so this is 3 cube root of 8 minus 3. Cube root of 8 is 2. So this is 3 times 2 minus 3. So the answer is 3. That's example 3. Example 4. If I take the integral from negative 5 to 5 of e dx, e is constant, okay? And so if it helps, move the e to the outside of the integral. So I'm going to take the integral from negative 5 to 5 of x dx. Excuse me, that's not an x. That should be 1 dx. And so this is e times, think of a function whose derivative is 1. And that's x, right? And so I'm going to evaluate, so I draw that line, I'm going to go from a lower limit of negative 5 to an upper limit of 5. So this is e times, replace x with 5, I get 5, minus, replace x with negative 5, I get negative 5. And so 5 minus a negative 5 is 10, and so the answer is 10e. That's example 4. Example 5. Suppose I had this. One that I want to point out because it's very fast. Suppose the lower limit and the upper limit match. So in other words, suppose the lower limit and upper limit are 5 in this problem. And then we get t squared plus sine t. So you're getting something totally outrageous to integrate. If the upper limit and the lower limit match, the answer to this question is 0. Okay, immediately. So generally speaking, the integral from a to a of f of x dx is 0. So if the lower limit and the upper limit match, you get 0. Done. Let's go ahead and do another one. So we'll call this example 6. Suppose I had the integral from 0 to 4 of 4 minus x square root of x dx. Now, before we do anything, I'm going to distribute the square root of x in. And so I'm going to write this as the integral from 0 to 4 of 4 root x minus x root x dx. Okay? And so this is the integral from 0 to 4. And so I'll write this as 4x to the 1/2 minus x to the first times x to the 1/2 dx. And so this is the integral from 0 to 4 of 4x to the 1/2 minus x to the 3/2 dx. And so this is 4 times, when I add 1 to the half, I get x to the 3 halves, right? But you have to divide by 3 halves. And then I'm going to add 1 to this exponent, which makes it 5 halves. So I'll go x to the 5 halves divided by 5 halves. And I'm going to go from 0 to 4. Okay? Now, when I divide by 3 halves, that's the same as multiplying by 2/3. So I get 8/3 x to the 3 halves minus 2/5 x to the 5 halves from 0 to 4. So I'm going to pop the 4 in for x. When I plug in 0, it goes away. So I get 8/3 times 4 to the 3 halves minus 2/5 times 4 to the 5 halves. Square root of 4 is 2, and then 2 to the 3rd is 8, right? So we get 64/3 minus square root of 4 is 2. 2 to the 5th is 32. 32 times 2 is 64. So we get 64 over 5. Now, I'll show you maybe a different way of how I do a problem like this. So if I'm very old school, so if I have 64 over 3 minus 64 over 5, what I would do is factor out that 64. And if you do that, you get 1/3 minus 1/5. Now I could do that, okay? So this is 64 times 2 over 15. So, because I could do 1/3 minus 1/5, right? And so the answer to this is 128 divided by 15. And that was example 6. So let's do example 7. Suppose I give you something like this. The integral from -1 to 1 of 3u minus 2 times u plus 1 du. So we got to multiply this out. It should be your first reaction. So we got to know what that integrand is. So we get integral from -1 to 1 of 3u squared plus 3u minus 2u minus 2 du. So we get -1 to 1 of 3u squared plus u minus 2 du. So this is u cubed, right? That's the function whose derivative is 3u squared. Plus 1/2 u squared, that's the function whose derivative is u, minus 2u from -1 up to 1. Okay? Pop the 1 in. So this is going to be 1 plus 1/2 minus 2. And then I'm going to plug in -1, and we're going to get -1 plus 1/2 plus 2. So the 1/2s cancel, and this is going to be -1 minus 1, which is -2. And that was example 7. Example 8. So we'll do a couple more for this video. So in example 8, we have, so we can knock out this one real quick. So the integral from 0 to pi over 3 of secant theta, tangent theta, d theta. So I want to give you enough variety, okay? And you want to think of the function whose derivative is secant theta tangent theta. But that's secant theta. So you get secant theta. Again, that's the function whose derivative is secant theta tangent theta. And that's going to go from 0 to pi over 3. So this is secant of pi over 3 minus secant of 0. But secant of pi over 3, okay, I don't know. So I do this. Secant of pi over 3 is 1 over cosine of pi over 3. But cosine of pi over 3 is a half. And so I know that's going to be 2. Secant of 0 is 1. So you get 2 minus 1. So the answer is 1. So that's how that works. Example 9. So we'll keep going. We'll do a little bit more. Suppose I had the integral from 0 to 3 of 2 sine x minus e to the x dx. Okay, think of a function whose derivative is sine x. And you're going to find that that's negative cosine x. Because remember that the derivative of cosine x is negative sine x. And so negative sine x times negative 2 is positive 2 sine x. The antiderivative of e to the x is e to the x. And we're going to go from 0 to 3. So we're going to put 3 in, put 0 in, and subtract, okay? So we get negative 2 cosine of 3 minus e cubed. And then I'm going to go minus 2 cosine of 0 minus e to the 0. So this is negative 2 cosine of 3 minus e cubed. So I'm going to take that quantity and I'm going to subtract negative 2 minus 1. And so the answer here is negative 2 cosine 3 minus e to the third plus 3. Because this is negative 3, and when you subtract a negative 3, that means to add. Okay. Example 10. Suppose I give you, well, I can give you this one. The integral from 1 over root 3 to root 3 of 8 over 1 plus x squared dx. And this will be our lesson today. And so I need to think of a function whose derivative is 8 over 1 plus x squared. And that'll be 8 arctangent of x. And we're going to evaluate from 1 over root 3 to root 3. Now, so this is 8 arctangent of root 3 minus 8 arctangent of 1 over root 3. Okay, so I pop the upper limit in, pop the lower limit in, and subtract the results. That's how the fundamental theorem of calculus works. And we're doing this every time. Okay, now, if y equals arctangent of root 3, then tangent of y is root 3. So in other words, I want to know what that y is. And remember, you have to be between negative pi over 2 and pi over 2. Okay? And so this is over 1. And so that's how I'm kind of thinking about it. And so this is going to be 8 times. Now, I claim it's either, if we let y be pi over 3. So this is how I think. Tangent of pi over 3 is sine pi over 3 divided by cosine of pi over 3. And then I go sine of pi over 3 is square root of 3 over 2. Cosine of pi over 3 is a half. I get what I want, okay? And so that's got to be pi over 3. And then I'm going to subtract 8 times, and I claim the other one will be pi over 6. But 8 pi over 3 minus 8 pi over 6 is the same as 8 pi over 3 minus 4 pi over 3, which is 4 pi over 3. And that'll conclude this video for section 5.3. This is 10 examples on evaluating the integral. And we applied the fundamental theorem of calculus part 2. All right, thank you.